All right, so we are going to transition now to our second talk of the day, which is entitled Next Generation Operations with ZIO. This is going to be an exciting talk by Adam Fraser. Adam Fraser is a software engineer passionate about using the power of functional programming to solve hard business problems. He is one of the top contributors to ZIO, a library for, as you know, a library for async and concurrent programming in functional Scala. He's also the co-author of ZIO Test, the author of ZIO Query, and the primary author of Zeometric. He's also a regular conference speaker, writer, and mentor to other software developers regarding functional programming. So without further ado, let me introduce you to Adam Fraser.
Thanks so much, John, and thank you all for joining today. Really happy to get a chance to talk to you today. Give me 1 second. Let me share my screen here, and then we can dive in. All right, awesome. So today I'm here to talk to you about next generation operations with ZIO. So one of the features that ZIO 2.0 brings is a focus on operational concerns and on bringing tools to help us all deal with that. And I want to spend some time talking today about first, what are operational concerns? So when we talk about operations, are we talking about HR? Are we talking about deploying clusters? What are we actually talking about here? And then we'll spend some time talking about why that's coming into ZIO Core. Is that just part of our sinister plan to take over the world by giving you high quality ergonomic software that's easy to use? Or is there something more than that? And I'm going to try to convince you that there's actually a deeper reason that that actually needs to be in ZIO Core that's going to tell us something about functional effect systems and really about the way information flows in functional effect systems. And then we're going to dive into two major features of operational support that are new to ZIO Core and ZIO 2.0, which is both logging and metrics being baked in. We're going to hit a little bit on tracing, but we're going to spend less time on that because that's something that is new and improved in ZIO 2.0, but not new in ZIO 2.0. So first question, what are we talking about here when we talk about operations? And the way I like to define it is operations are how we understand what's happening in our application without us having to go back and change our source code. So when we're doing local development and something's not working and we add a debug statement, that is not having operations. That's the definition of not having operations. And so we can think about that as answering questions like what happened with different logic did it have. We can also think about it as data like how quickly are we responding to a request? Or if a failure occurs, where did it occur? And practically, we can think about it as when we have our large application, we deployed it and things aren't working, how do we figure out what's not working so that we can fix it on a timely basis? Because I think one of the things we realize as we start to code more in the large versus in the small is that the tools we use for programming the small don't necessarily scale up. When we're doing our little pull request and we're doing an algorithm or something like that, we can just add those debug statements, we add some unit tests, and we feel good about that. And if something doesn't work well, we just tweak it a little bit, we add a statement somewhere else, and we have this rapid iteration cycle. But when we have these large applications, there's a very significant lead time to just deploy them. Of any time we say, well, okay, if we add this information here, this will help us diagnose the problem. It's, depending on our infrastructure, hours, maybe more, for us to actually get that to a point where we can see the impact of that. And that's especially true if we have something where maybe the issue doesn't always occur. Maybe the issue only sometimes occurs or occurs after a period of time of we deploy the application and it goes fine for 24 hours, but then it seems to run out of resources somewhere. Well, you really don't want to be in a situation where you have to change something and redeploy and then wait another 24 hours. That's a cycle time that's too long. It's going to lead to you failing to address the needs that our customers have, whether those are internal business customers, whether those are clients we're working with. We're not going to be able to actually achieve what we need to do and solve problems if we're iterating at that slow of a pace. So these operational tools are the things that let us see what's going on without doing that, changing our code and redeploying and diagnose and get to a point where we say, okay, this is what the problem is, let's go and let's fix that problem. So there are a variety of operational tools that we can use. The ones we're going to focus on today, first, logging, which we can think about as qualitative information about what's happening in our application. Typically text-based, can be more structured, but qualitative versus quantitative information, which we could think of as metrics. And then, as I mentioned, we're going to talk a little bit about tracing, which we could think of in a way as more detailed qualitative information when an error occurs. If we logged at an extremely fine level and every statement we logged what we were doing, then in a way we wouldn't need tracing, because anytime a failure occurs, we would just go back and we would look at all the logs, but we don't want to do that. So we can think about tracing as almost when a failure occurs, going back and grabbing a bunch of the logs for that particular logic path that failed, and then letting us view those. So what do those things look like in ZIO 2.0? What does ZIO bring to the table here that's different than what we had before? So here's what logging looks like. And here we're going to call this ZIO log span operator, which is going to define a new span. So in this case, we say, okay, everything we're doing within this scope is related to parsing in this case. And anything we log here is going to have metadata, to go back to the previous talk, attached to it that we are in the span of doing parsing here. And we can nest these spans. So we might be 7 levels down in other spans, but at least the most inner span right now is this parsing one. And then we're going to open this file and we're going to parse its contents. And we're going to do that with this ZIO acquire release with operator, which if you've used ZIO 1.0, this is the new bracket. So this is the operator that we use for safe resource handling. And now it has an even more intuitive name of we're going to acquire and release the resource. So we're going to open this file and we're going to parse its contents. And we're going to say, when we're done working with this file, no matter what happens, whether that's because we successfully have parsed it all, whether that's because there's some error that occurs, whether that's because we get interrupted, we're going to make sure we close the file. And the one thing beyond just the name of acquire release with being different here, that's different this time, is we're doing this catch-all and we're saying ZIO.log error. So in ZIO 1.0, one of the things we always say is that finalizers can't fail. They have to be unfailing, and that means that there are two things that you do with the possibility that a finalizer can fail. You either, if you think this is a critical thing to close, then you convert that to a fiber failure, or you log it. And we always said those are the two options, and if you don't want to fail your application, you log it. But in ZIO 1.0, that was a little bit conceptual of if you said, okay, well, great, how do I actually log it? We didn't ourselves have a tool to log it. We said, well, log it however you log it. If you use log4j, then use log4j. Use whatever you use to log it. But we didn't have our own thing to log it. Now we do. And we'll come back a little bit later to some of the deeper reasons why it's important. But right now, you can just see there's a built-in operator to do this. And you can log at different log levels. And we'll see later on how, in addition to defining these log spans and being able to log anywhere in your application, you can also plug in any logging backend you want to. So here you're defining what you want to log. And later on, when you put together your whole application, you're able to define essentially where you want to log it, how you want to execute that logging. Second thing that's coming to ZIO 2.0 is metrics. And so you can see here an example of we're defining a counter, which is a metric that's just always going to be incremented when something happens. So that could track something like cache hits or the number of a particular type of requests. And we can see that we can do something here. Here we're getting a value from a cache. And if that value is in the cache, then we're going to call this track hit. And that's going to increment this counter. And all of these metrics, support for a whole wide variety of these metrics, gauges, counters, histograms, summaries, set counts, and all of them we can apply either using this aspect syntax here. So we can treat any metric as something that we add to a ZIO workflow, and it adds metrics tracking to whatever that workflow is already doing, as well as we can just call methods directly on it. And again, we can plug in any metrics backend that we want to support, and we can even support multiple metrics backends at the same time. So if you want to, you can send it to SD, you can send it to Prometheus. If you wanted to, you can send it to both. We'll see later on, we've even got a special development mode server for that, where you can see things in your own local environment without having to set up any of those services. So again, gives you an easy ability to describe the metrics you want to track separate from actually where you want them to go. And then finally, we've got tracing, which is the one that is not new to ZIO 2.0, but improved. More than twice as fast as in ZIO 1.0 for pure code that is not doing anything but flat maps. So definitely for higher level applications, don't necessarily expect to see that level of improvement. But if you think about the overhead that these effect systems are bringing, we always want to keep that as low as possible. And this is another step in that direction of giving you the benefit of this execution tracing in the event of errors and making it as low overhead as possible. And then the other thing that's coming in ZIO 2.0 is improved rendering of that. So I think one of the things that we've definitely heard feedback on in ZIO 1.0 is you get the execution traces, and the execution traces are fantastic versus not having execution traces, because you can go through and you can see where your error occurred. But right now there's a little bit of digging through, because there's your code and then there's also the ZIO code. And in ZIO 2.0, we're essentially going to get all that ZIO code out of those execution traces. So all you see is your code and exactly where the failure occurred and exactly what logic path you were on that got you to that failure and what you were supposed to be doing next. Okay, so that's what's coming to ZIO 2.0. Next question is why? So why are we including this in ZIO? Is it just kind of a, oh, well, the ZIO people like to bundle things together and other people like to make them more modular, and it's just kind of 6 of one, half dozen the other? Or is there something deeper going on here? And I think there is something deeper going on, and there are really 3 parts to it. And I'll build up from the super practical to the more conceptual, but maybe more important, actually. So the first reason is easy onboarding. And we want to make it as easy as possible if you're getting started using ZIO to get going. And we recognize that for modern organizations today that are trying to do something, these operational concerns they're not optional, they're mandatory. This is not something where we say, well, maybe you're going to use GraphQL, maybe you're not, maybe you're using SQL, maybe you're not. Essentially, if you're doing serious work, you're going to want logging, you're going to want these metrics to understand what's going on in your application, because whatever you're doing, it's going to have some complexity, and as much as you try to, it's going to have issues, and you're going to need to identify those issues and be able to react to them rapidly. And we want to make that easy. We want to reduce questions when people are getting started. I think a lot of organizations I talk to, when we get started, they know they need logging, and they say, well, does ZIO have logging? And say, yes, we have ZIO logging. And then there are questions of, well, is ZIO logging just like its own logging framework, or is it a front end, and how do you connect it? And there's just a set of things you need to figure out, and none of them are hard. And I think lots of people have done them in ZIO 1.0, but we want to make it even easier and provide a even more out-of-the-box solution, because we recognize that when you're starting to use a new application like ZIO, in a way, you're probably already under the gun. You're moving to ZIO either because you're on some more legacy system that you recognize is kind of not the future, and you don't want to keep incurring that technical debt, or because you need some functionality to do something you want to do that you don't have today, or you're trying to prototype a new application and you want to demonstrate the value of that in your organization so you can get more resources on it. And kind of whichever one of those it is, you're already like a day behind, and we don't want to make you do any more to solve your problems. So the more we can get out of your way and just have this stuff for you, the better. So that's point one. Definitely makes sense, but also pretty tactical, pretty blocking, tackling. Second point, getting a little bit more abstract, is this is an opportunity for us to create a community that shares best practices around these operational concerns. So I mean, I'll just speak for myself. When I was learning Scala, probably like a lot of people, I started with Marno Dersky's course, and it was fantastic, but it did a lot to show the beauty and the elegance of Scala, but I don't think I ever used logging there. And in a way, you don't need to when you're doing that programming in the small. But I think sometimes the downside of that is probably if you're newer to software development and you come into a big organization like Capital One and they tell you use logging, they tell you use metrics, you may never have used those tools before. And it's not like they're rocket science, but it's definitely valuable to have used these things before. And there's also value in having a set of community best practices. So even a lot of these large, sophisticated organizations I work with, I'll sometimes get questions of, well, how much should we be logging, or how should we be logging? And sometimes people are not logging at all, or sometimes people are logging every statement of, I'm about to add 1 and 1, and okay, I successfully added 1 and 1. And there's not necessarily, I think, a best practice out there that is widely shared. And I think this is an opportunity for us as the ZIO community to start to build that, where when you hire a ZIO developer, just like you can expect that that person knows how to use for each par to run a bunch of effects in parallel and collect their results, that you expect they know something about how to use logging, about how to use metrics. And we can all together develop a view of how to use these in a idiomatic way. Just like we talk about the error channel, and we have best practices about what things should be go in the error channel versus should be die failures. We can get to a point where we have best practices about what type of metrics we think it makes sense to record, what types of logging it makes sense to record. And we can start to actually use that in open source projects. So one of the things we're going to get to in a second is, right now, a lot of these tools are used primarily in userland code, but not necessarily in libraries. And so there's not that forum for developing that shared knowledge and for getting to those best practices. The final reason that it's important to actually build this in at the base layer is, it gets even more conceptual, is really about communicating information. And these tools of logging and metrics give ZIO ecosystem libraries a common language to talk about these operational concerns. So currently, if I'm an organization, if I'm Capital One, I may have other issues with logging or metrics, but I don't have an issue with just using those tools. I can bring in dependencies, I can use them, that's fine. But if I'm a ZIO library, if I'm writing ZIO Test or I'm writing ZIO Query, I've got a little bit of a challenge if I want to use any of these tools in ZIO 1.0 or kind of in the world before ZIO 2.0, because I'm probably pretty hesitant about bringing in additional dependencies, and I don't want to force a particular solution on my users. So I don't necessarily want to say, well, okay, I'm going to depend on this logging library, because then I push everyone downstream of me to use that logging library, and I may not be kind of important enough to them to have them want to use the logging library that I want to use. And so I'm in a little bit of a tough position of what am I supposed to do? I mean, maybe I think the answer a lot of libraries use today is, well, I'm not really going to do logging or metrics internal to my library. I'm going to let users log or record anything they want around the operations of my library, but I'm not going to myself say that I'm going to log, well, within ZIO Query, we're starting to execute a data source, and now we've done executing that data source, or anything like that. Maybe if I really wanted to, I could kind of roll my own system, but again, that's probably not what I want to do. I want to be solving whatever problem my library has. I don't want to be making my own version of a mini logger or mini metrics. That doesn't really make sense. And so I think one of the things that we can expect, and that we also need to work towards as a community, is to take advantage of these tools to build a much higher level of operational information that we're providing our users. Where if you think about something like Spark, as soon as you get Spark going, it's going to use some logger, whether it's the console or something else. And as it's doing things, it's going to tell you what it's doing. It's going to say, okay, I'm executing this RDD and I'm putting these things together, and well, I didn't have this. And I think that's something that as we grow up, we're going to need to provide more and more of. And as users of ZIO libraries, you should be expecting more and more of. And there's really a conceptual reason underlying all of this, which is, if we think about it, functional effects are binary. So if we look at this ZIO REA, and kind of the fundamental thing is, okay, this is a computation that we can run it, and we can get this exit value. And the exit value is one of two things. It's either a failure that has error or a cause, or it's a success that has a value of type A. And it's always either one or the other, and it's never both, and it's never anything other than those two things. And that makes a lot of sense for functional effect systems in a way, because we need to make a decision of, are we going to continue with the computation? And if we've got an A, then we can continue and we can do something else with it. If we don't, then we've got to stop. So that's all great. But what we run into is this situation where, even though functional effects are binary, the world isn't binary. So here's a simple example of this, where we're forking this background fiber, and we're never joining that fiber back. So we can imagine that this fiber that we're forking is supposed to do something, maybe it's supposed to send a heartbeat signal somewhere, but something went wrong, so this fiber failed. And there's a little bit of a question here of, what should we do with this failure? We're not joining the fiber, so it's not part of that E-type. Its result is not our result. We've got a result that's independent of that. But it still seems like the fact that this fiber failed is potentially relevant. So we'd like to do something with it. But if all we have is this E and the A, we don't really have any place to put that fiber failure. And so in ZIO 1.0, the best we could do was either log it to the console, or maybe we could allow the user to specify some handler of what they want to do with it. But it was really a suboptimal solution. And I think if you go back to like before ZIO 1.0, there was actually, we spent significant time kind of thinking about how to handle cases like this. And we had these different principles, because you can imagine other cases where actually you don't want this logging to be warned of. You race two effects, and whenever you race two effects, one of them loses and you interrupt that one. And if you race a lot of effects, you could get a lot of these fiber failures that you aren't joining back, and you could get a lot of logs being printed. And so we actually got user complaints that there were too many logs. And we spent a lot of time thinking about, like, okay, is it Is it because it's being interrupted that should be treated differently? Like, what's kind of the underlying principle here? But I think looking back, it was really reflecting a more fundamental issue that we didn't have this tool of being able to communicate this additional information in a more structured way. And so, again, thinking conceptually, it's really this issue of we're taking this non-binary world and we're trying to compress it back into these two outcomes. And these two outcomes are not big enough to incorporate all the information about the non-binary world. So it's almost if our significant other asks us to go out and get some groceries, and we can come back and we can say, here are the groceries, right? That's a success. Or we can say, I don't have groceries, and we have some failure of the store was closed or they didn't have the ingredients. But we have no way to have any other information. We can't say, well, I got the stuff in the store, but I noticed the car was low on gas. We should make sure we fill it up tomorrow before that trip. Or I saw Joan and said her husband is sick. We should send them something. You have no way to convey that information. And so we kind of have these like very poor substitutes for that historically of, well, maybe we render it to the console, but depending on what we're doing, that console rendering may not even be visible if this is on a distributed system. Also pushes us to have these very arbitrary decisions of, we basically have to say like, is it important enough that we're gonna like display it on the console and take up this like limited real estate space and potentially overwhelm the user? Or are we just gonna throw it away entirely? And we don't really have anything in between. And probably whichever one we do, we're gonna disappoint some users, because for some users or some use cases, we're either going to give them too little or too much information. And then we can try to do this thing where we kind of provide we ask the user to tell us what they want to do with a function. We say, well, if a fiber failure occurs, tell us how you want to report the failure. And so like that's what we did in ZIO 1.0 with the runtime, where it had a function that you specify to do that. But that doesn't really scale. Maybe we can do that for one or two things in ZIO itself, but how many different examples of this can we come up with? And we'll pretty quickly come up with a lot more. And it's not feasible to ask the user for every one of them to specify what they want to do with this. We need a more structured way to do it. And in fact, we kind of already have a structured way. And it's these tools like metrics and logging. So what all of this is really leading us up to say is that we need another information channel for this. We need another way to convey this information that is able to support arbitrary metadata, that's able to say, okay, we've got the E and the A, but there may be other information we want to convey that isn't reflected in those type parameters. And that's essentially how we can conceptualize these operational tools. Logging is a way of providing structured qualitative metadata. Metrics are a way of providing structured quantitative metadata. And so this, in a way, we haven't invented anything new. We've gotten back to metrics and logging, which there's an existing community of practice around, an existing set of tools around. But what I think we've gotten from this is an understanding of why we need this and how it fits. That it's not just, well, these are some tools and we should use those tools, but that it's actually addressing a pretty basic need we have, a need that's in a way stronger when we have these functional effect systems. Because if we were doing purely imperative programming, then we could just maintain whatever state we wanted, and we could just write this stuff anywhere, and we wouldn't really need this separately. We could just handle it as part of everything else we're doing. But if we're really programming in this model of values, where we just have this ZIO REA that either gives us an E or gives us an A, then we really have this problem of we've only got these two possibilities, but we've got the world that has more nuance to it. And we need a tool to convey that nuance. And that's essentially what these operational tools like logging and metrics do for us. And once we start to see this, then it's one of those things that I think is pretty hard to unsee. And once we added these tools, we started noticing more and more places in ZIO that we could use them. And we had been struggling with this issue of not having enough tools to convey information. So like you can go back to the example with acquire release from the very beginning of this talk. where we were able to tell users, hey, if you want to convert it into a fiber failure or log it somewhere, but if I'm writing my own operator within ZStream, say, and I have some resource where I want to record the fact that the release failed, but I still want to continue, I didn't have any principled way to do that. The best I could do is try to log to the console, which has the issues that we just talked about, because I didn't actually have the ability to do logging from ZIO, because that wasn't available at that level. It was only available at a higher level. And we see more and more places where that comes up. So here's another one from ZIO Test. So this is a test that involves something called the test clock. And ZIO Test, which is the test kit that comes with ZIO for testing ZIO applications, has this really nice functionality to test effects involving time without having to actually wait for time to pass. And you can use it to test even quite sophisticated logic involving time. So like this test here is testing a stream operator that's going to combine two streams and emit pairs of elements as soon as it gets a new element from either stream. And we want to verify that this gives us the correct results when we have streams that emit elements at different frequencies. And we can use the test clock to do that in this pretty straightforward way, where we create this queue that's going to have the results of the streams. We offer values to them, we collect those, and we just adjust the clock. But the one probably biggest complication people have with a test clock is you actually have to call that adjust method. That the test clock gives you the ability to control the time, but it also means you actually have to control the time. That if you don't tell it to advance the time, then time won't advance. And so we like to be able to print some kind of warning if you don't do that. And in ZIO 1, we were able to do that a little bit, but we did it in that way that was probably not the most ideal way of, we just printed something to the console. And for ZIO Test, maybe that was fine because a lot of your testing is console driven, and whether you do it locally or you have it in CI, you typically have tooling built so that you can see that console output. But again, not really ideal. And once you have these tools, as soon as we had this, we're like, oh, we should log this as a warning instead of just printing it to console. And you see more and more things like that of, well, for a while, we've been interested in providing more information about test results over time. So imagine being able to see over the last 6 months, which tests have ever been flaky? What percentage of the time have they failed? How has the average time we spent on testing changed over the last 6 months? We didn't really have a tool to do that. Now that we have metrics, we're like, this is exactly the tool we were looking for. And we have something that lets us do that in a principled way versus that being kind of a one-off feature request. So hopefully this gives some sense of why adding these tools to ZIO is not just a, oh, let's bundle it together, but actually has a pretty deep structural reason why this needs to be at the base level. So, okay, we said we need this. How do we actually provide it in ZIO? Because there are some challenges to doing so. So let's start with logging, and let's think about the design goals that we need to achieve in doing this. So first one is we want it to be simple. We also want it to be extensible, because other people may want to build more sophisticated logging solutions on top of it. And there are a lot of different ways that people can want to do logging. They can want to do structured versus unstructured logging. They can want to log with 7 log levels, or with 12 log levels, or with 5 log levels. They can want to use spans differently. They may want to have different concepts of how they do the logging. So we want to support all of that. And then we've also got to do all of this without actually depending on any actual logging framework or library, because at this level of ZIO itself, we want to be zero dependency. So how are we going to do all these things? Well, we're going to take a little bit of the, I guess what you could think of as the usual ZIO approach, And we're going to think about separating, describing, and doing. So we're going to provide a front-end interface that essentially lets you just describe what you want to log without specifying what it means to log it. And then we're going to provide a back-end interface where you just describe how you want to execute that log statement, what it means to log something. And the ZIO runtime is going to wire those things together for you so that as long as you do the first one, you do the second one, those are going to fit together in all the right ways. So what does that look like? Well, the first step of it is just this log method here, which just lets you take a message you want to log and is going to return this new primitive within the ZIO data type, this log thing. So just like within ZIO, there's flat map or there's fold, there are these primitive operations that are used to build all the other operations that are essentially the language of ZIO. There's a new letter in the ZIO alphabet of this log thing, which is essentially just an instruction of when the ZIO runtime is executing this program and it gets this log statement, log this thing. And we'll see later how we interpret what it means to log the thing. But right now, this is just a description of, I have an intent to log this message. So the question you're probably asking now is, where's the beef? Where's the different log levels? Where are the log spans? Where is the structured logging? This is like great as like a toy example of logging a message, but where are all these other tools that we expect from a real industrial strength logging solution? And the answer is we can get basically all of these using an existing ZIO data type we have called fiberref. And fiberref you can think of as it's a mutable value, or it's a description of a mutable value, I should say, that is specific to a particular fiber. And its defining method is this method called locally, which lets us set that fiberref to a new value for the duration of a particular effect. And then as soon as that effect is over, whether it's because it completed successfully, it failed, or was interrupted, the value of that fiberref is going to be restored back to its original value. And so this is a really good tool for passing information about context that may be changed locally. And the fact that the fiberref is local to a particular fiber means any changes we make to it aren't going to be visible to other concurrent processes. So this is a tool that you're actually going to see being used more and more in ZIO 2.0 in other ways. And it is really nice for this context that you may want to change. So for example, in ZIO 2, you're actually, whenever you do for each par, you're not going to have to do for each par n and specify the level of parallelism for each individual operator. You're going to be able to specify that for a region of code. And so for your whole application, you might say, well, my default parallelism is my number of cores. It's 8 cores or it's 16 cores. And then anytime you use a parallel operator, that's the parallelism we would use. But if for any operator or any part of your code, you want to use a different level of parallelism, then you would just, or an operator would just for you, use this locally thing to change that to some other level of parallelism. Say, well, I want to do this part with unbounded parallelism, or I want to do this part with only 4 concurrent fibers. And so we can use this tool to essentially solve all the other problems we have with logging here. So let's start with log levels. So we can create a simple case class here that's going to represent a log level. And it's going to just have this ordinal value that is essentially the importance of the log level. It's going to have a label, so we might call it error or warning, or we might make up our own. And then it's going to have a system log level severity. And we can provide some of our own. If we can define an error as a particular log level, info is a log level, warn is a log level, though you can also provide your own. And we're going to have this fiber ref that's going to have the current log level inside it. And so what that means is if I want to log something at the error level, all I do is I take that current log level and I say, well, locally, change the log level to the log level of error, and then log that message. And we'll see later how the interpreter of that log instruction gets to look at that fiber ref. But that gives us all the information to know what log level we want to log at and to describe that. And this lets us actually separate what we want to log from even how we want to log it, from the log message from the log level. We can do the same thing with log spans. So we could define a log span here as having some label that's going to describe the span of the log. And then it may have some additional metadata attached to it that we want to record of, let's say, when we started the span, so that when we get to the end of the span, we can look at that and we can see, okay, how long have we been in the span by the time we log something. And again, we can create a fiber ref to contain this log span, except this time, instead of it just being a single span, it'll be a list of spans. So we can think of that as a stack of spans. And that way, every time we create a new span, we'll just push it onto the stack. And then when we go to log something, we'll be able to look at the whole stack of spans that we're logging with it. And so here's what it would look like to log with log spans. And again, it's pretty simple. We're using the same locally thing. Most of the complexity here is actually just in a little bit of really UI we're doing here to just try to make this a little bit more ergonomic. But what we're saying here is when we call it that log span thing that we saw near the beginning, and we give it a span we want to create, it's going to create this new ZIO log span thing, which we can think of as almost a builder of an effect with a span. And it's just going to have this apply method that takes the ZIO effect we want to run in that span. And what it's going to do is it's going to get the current log span. And so that's going to have a stack of the current spans that we're in. And then locally, we're going to push a new value on the stack. And locally is going to make sure that when we're done with this effect, we pop that value back off the stack. And within this effect that we're running, anytime we call log, we're going to be able to look at these fiber refs, and we're going to be able to look at this log span fiber ref, and we're going to be able to see all the spans that we're in. And we'll be able to use that however we want to for actually writing our logs somewhere. And so you can see this gives us the ability not just to set the log span for a particular thing we want to log, but we can even set the log span for a whole region. So we can say, well, maybe my whole program should have a log span of the name of my program. And then within that, we should have inner spans for these particular modules or for this particular request. We can do that however we want. And we can compose these spans together to create nested ones. Okay, so final challenge here then is, how do we support structured logging? So far, our primitive was this just log a message of a string. And depending on your organization, for some people that's great. For some people, they'd say, well, that's an anti-pattern. I want to log in a more structured way where I want my log to have type values, if I want it to have a correlation ID, or I want it to have this field or that field, or what server I'm on. And again, the way we can do that is we can actually use this fiber ref tool again, and we can make our own fiber ref that is going to contain these different fields we're interested in. We can make it contain the correlation ID, and we can fill in the fiber ref with that. And we don't even have to do it at the level we're logging at. We can do it at a higher level of when the request comes in, we can create the correlation ID. And then we can just have that to grab for all the logging we do within the scope of that. And we'll see, we can create one of these, we can create multiples of these if we want. And then when we're actually going to execute the logging, we can grab all these things together and we can put them into a more structured value if that's what we want to have. So that's how we describe what we want to log. And hopefully now we see how we can actually describe everything we want to log. Next question is, okay, how are we going to actually execute that log? If all this stuff is now sitting in the ZIO runtime somewhere, how do we actually write it to some kind of data source that, or data destination that is going to have this? And that's where this Z logger comes in. So the logger is essentially the how we want to execute these logs. This is what the ZIO runtime is going to call every time it sees one of those log statements. And you can see here all the information that the logger gets to access. And it's all the information that we would need to access everything we created in our description and to create whatever kind of log we want to. So we've got here some information that's more specific to the ZIO runtime that we think would be probably useful to you, of what fiber are we on when we're executing this log, what's the current trace. So that goes back to that idea of execution traces. And then we have a couple where we've essentially pulled out some of those things from the fiber ref ourselves, just to make it easier for you if you're implementing one of these loggers. So you get to see what the current log level is. You get to see what the current stack of spans you're in. You get to see the message. And then you've got this one here called context, which gives you access to other fiber refs that you may have created. So if you created a correlation ID and you put something in there, this is where in your implementation of your logger, you're able to go and you're able to grab those things and use them to make whatever logging result you want. And the other thing to note here is that this actually gives you a typed value. This gives you an A. And sometimes this A may just be unit or any, because you're just doing the effect here. We're finally executing something. So you're doing the side effect of writing this to some file. But it can also return a value. It could return a case class that describes your structured log, and that then could get composed with other loggers to actually do the writing to the file. So it gets access to all this context, and it can either produce a value or it can do something. And the other neat thing with these loggers is that they compose together. So we can combine two different loggers and say, well, I want to send my logs to both places. Maybe I want to do console logging and I want to write it to some persistent source that's going to be more durable, where I can go back to it later. I can filter the log levels, and I can say, well, only if, at least for what I'm doing right now, only show me things, only even bother logging things that are above a error level or above a warn level. And I can transform the results of the logger. So I can say, okay, well, I have this logger that just produces a value for me, that just produces some case class, but now I want to do something with that case class. I want to write that to a file. And so I can put these loggers together to do all these different things. And that's really where ZIO logging in this new world is going to come in. ZIO itself is creating these hooks. It's creating these hooks where you as a user have the tools to describe whatever you want to log. And this backend where implementers of loggers can get all of that information and use it to log something. But again, in ZIO itself, we don't want to add dependencies on particular logging frameworks, because you may not be using those frameworks. But what ZIO logging will do in this ZIO 2.0 world is they will have the implementations of all of these different loggers. And so what you'll do is you'll write your whole program using those operators, ZIO.log, and then you'll get your logger, probably from ZIO logging, unless you're doing something very customized. And to plug it into your application, this is all you're going to have to do. You're just going to get the default runtime configuration, and maybe you'll want to customize in other ways, but right now you'll say the only thing you want to do to customize is you want to provide a particular logger. You'll get that logger, you'll do import zio.logging.xyz logger, and you'll just say logger equals XYZ logger. And then you'll just run your application with that runtime config. And that's all you have to do to wire up whatever logger you want to. And if you wanted to, you could make this XYZ logger plus ABC logger, and you could log to both of those places. And then ZIO logging will also be able to provide potentially higher level logging functionality of if using these operators, there are additional, more logging specific combinators they want to provide. That can also be a place where that lives. But the primary goal of ZIO logging in this world is really going to be providing these implementations so that whatever framework you're using in your organization, you can just grab the appropriate implementation and just plug it in. So putting it all together, we come back to this example of acquire release with. And now hopefully we've got a better understanding of both why this is necessary and how this is being implemented here. Of this log span is just pushing something onto this fiberref stack of this list of spans we're on. We're running this acquire release with. If we get an error, we're adding a new instruction to the ZIO runtime that's going to log that error. And that this is giving us this principled way of expressing the information that didn't just fit into the E and A types of the acquire release is returning the result of this file or the error from opening or using a file. So we had this other information of was there a failure in closing the file and what was that failure that we didn't really have a principled place to put before, and now we do. So that's logging. Let's talk about metrics. So design goals for metrics, a lot of similarities. We want it to be simple. We want it to be extensible because people definitely have different metrics they want to record, different ways they want to record metrics. We want it to be zero dependency, which again is going to be a challenge for us. And here we also have an additional concern about performance, where probably in a typical application, I think our expectation should be that the number of times we record a metric should be, I think, dramatically higher than the number of times we log something. I'm not sure that's always true for all organizations I've seen, but I think that's probably a best practice, that if we're not doing that, we're probably logging too much. That the reason we're going from qualitative to quantitative information is because the number of observations we're seeing is just a lot higher. And because of that, it's more important than ever that we minimize the overhead of using these tools, because we want to be easy to be able to add these tools to any application. So how do we do that? Well, we're going to follow a similar strategy. We're going to have a front-end description of the intent to track a metric. We're going to have the back-end execution of a metric. And then we're going to have the ZIO runtime that is going to wire those two things together. And in this case, we're actually going to have a little more work to do, most of which we're fortunately going to hide from you, the users, to make this work. But we'll hit in a second on why that is. So front end first. Our key tool here is this thing we call a Zeometric. And a Zeometric is a type of ZIO aspect. So that means it's something that we can apply to any ZIO effect using that at syntax we saw before and add tracking to that effect. We'll see in a sec, we're going to have different subtypes of the Zeometric that let us add additional functionality beyond just applying it to an effect that reflects the particular type of metric we have. So do we have a gauge? Do we have a counter? Do we have a histogram? And these metrics are also going to have a metric key that uniquely defines them so that we can never accidentally create overlapping metrics, that the set of parameters that define a metric uniquely define how it's going to be looked up and associated in the implementation. And so from there, we have a bunch of specific subtypes of metrics. And these are essentially, you could think of as the union of the supported metrics types in the different major metrics frameworks like StatsD or Prometheus. So the first one is a counter here. So this is just a cumulative value that gets incremented over time. So this would be something like, how many of a particular type of request have I received? And its defining method is going to be this thing called increment that lets you increment the counter by a certain amount. And for all these, I'm going to try to focus on what we call the defining operators on them. Most of them have some additional convenience methods. So for example, on increment, there's another variant of this that just increments by 1, because that's a pretty common use case. But obviously, that's just calling increment with 1.0. Next one is a gauge. So a gauge is something that, as opposed to tracking a cumulative value, tracks a value as of a point in time. So this could be something like current memory usage. And so it comes with operators to both adjust it from its current level, as well as just set it to a new level. And you'll see each of these is defined with a name and then a set of tags, which are these metrics labels, which are key value pairs that are going to be used by the metrics backend and are going to let you sort and visualize this data in different ways supported by those frameworks. We also have histograms. So now we're getting a little bit more sophisticated here. These histograms are going to have a set of these boundaries that are essentially going to define buckets. And we're going to track the relative frequency of numerical values in each of those buckets. So I might have a bucket from 10 to 20 milliseconds. And we're going to say, okay, well, how many of our requests fall into that bucket versus less than 10 or more than 20? So we can use that for things like distribution of time to serve requests, where we're not just concerned with the average or the total, but we're concerned with what the distribution is there. Because sometimes either because things that are on one extreme or the other are actually more important than just what the average is. And this is defined in this terms of this method called observe that just takes a new value and just adds it to the appropriate bucket in this histogram. We've also got something called a summary, which is getting even more sophisticated here. So this one allows us to track a metric over a rolling time window and to record percentiles of that metric. So if I wanted to say, what's the 99th percentile of response time over the last hour, and I wanted to track that over time, I could do that with a summary. So this one can be particularly for things like service level agreements, where it's not just the average response time that matters, but it's the 95th or the 99th percentile of response time that matters. And you want to track that over some time window that's relevant to you. And then we also have one called a set count that lets you track the number of occurrences of different unique values. So this might be really good for something like frequency of different error types. So each error type would be its own essentially key in this map. And every time an error occurs, you would increment the corresponding key by 1. And you'd be able to see, okay, over the life of my application, here's how many of this type of errors I've seen so far. Here's how many of this type of errors I've seen so far. And so with those primitives, there are a variety of metrics that already exist in ZIO for common use cases. So things like counting successes, counting failures, counting how long an effect took to execute. There's also some really exciting metrics that just got added by Daniel, or Vigu, as he goes on GitHub. But these are metrics, they're specific to JVM on very operational performance type of things, object allocations, garbage collection, memory usage, some really cool stuff that is not easy just off the shelf to track without having a tool do it for you. And with this, just comes almost for free. You basically do one line to add this to your application, and you'll get metrics reported for this. So really, really cool feature. It's also really easy for you to add your own metrics. So if you want to define your own metric, all you need to do is you define one of these existing types. You say you want a counter, you want a gauge, and you define the supply method, which just says, when I apply this to a ZIO effect, here's how I want to use this metric. So like this metric here is going to count errors. And the way I'm going to implement it is I'm just going to tap error this thing. So just every time it fails, I'm just going to increment the counter. And that's obviously a simple one. I could do more complex ones where I get the time before the effect, and then I run the effect, and I get the time after, and I calculate the difference, and I put that in a histogram. And some of these you're not going to need because we already thought of them, we added them for you. But if we don't have one, it's very straightforward to add one of these yourself. So that's the front end. And then again, we have the back end of like, okay, we've written a check here of like describing this information. How are we going to go and actually execute this? And the main complexity here is that we want to be able to support metrics clients that are what I would call both push-based and pull-based. So some of these metrics clients, the way they work is essentially they say, well, we'll pull the data when we want it. So I'm going to, on some frequency or because the user asked me to, I'm going to query you for the metrics. And when I query you, you've got to give me the metrics. But then there are some of these other metrics clients that are more what you call push-based, where you say like, no, like whenever you have a metric event, send me the event and I will consume the events, but you send me the events as soon as they come in. And so one of the really nice things that the implementation of metrics and ZIO does for you is it completely abstracts over that, where the way you write your metrics is completely independent of that. And you can support one or both of those types of metrics clients at the same time. So the way you do that is we've got these two hooks that correspond to these two different ways that these metrics clients interact. And so one of them is this unsafe snapshot, which just gives you a snapshot of the state of all the metrics at a particular point in time. And so what that implies is that ZIO under the hood has to keep track of all these metrics for you. And so there's a decent amount of work that goes into having high performance, concurrent, safe implementations of all these things. But again, other than knowing it's there, you don't have to do anything with it. But what it means is that anytime one of these services that is more pull-based wants to know what the status of the metrics are, they can call this unsafe snapshot, they can get the status of the metrics, and they can handle it as appropriate for their implementation. And similarly, if you're a pull-based client, you can use this unsafe install listener method, which is going to install this metric listener, which is basically a bundle of callbacks that says, well, when you've got a gauge change, send me the gauge change, do this. When you've got a histogram change, do this. And you just provide a set of callbacks. And then every time metric gets updated, ZIO will do that. So we can support both of these types of metrics clients. And in fact, we can even support both of them at the same time. If you wanted to, you could send it to both places. And so the role of ZIO ZMX, or will be called Zeometrics in this new world, just like ZIO logging, becomes providing implementations of these metrics clients, where what we want is for you to be able to go to any metrics client you're using. Right now we have Prometheus and StatsD. New Relic is going to be forthcoming, and just say, okay, I'm using this thing. This is what my existing infrastructure is built on. Let me just grab this thing. And again, it's just one line of code to plug that in as where these metrics get sent to. And the other neat thing here is that in addition to all of those, what I'll call industrial strength backends being supported, there's a developer mode metrics server that we've developed that's going to come with Zeometrics. And that's based on the work of a team of ZIO contributors, and uses technology like Laminar and Scala.js to provide a metric server that lets you visualize these metrics without needing to install or set up any of these professional grade metrics backends, which definitely eventually you're going to want them professional grade if you're a large organization. But if you want to try this out, if you're looking to rapidly prototype something, maybe if you have those things, but you're just doing local development, it's really nice to be able to just see that stuff in real time without having to plug in any of those more heavyweight tools. And this is a really nice feature that's contributed by Andreas, goes by Atuni, has a funny graphic. So definitely, if you check this out and you enjoy it, say thank you to him. He's done a lot of really great work on this feature, as well as on ZIO, I guess the artist formerly known as ZIO ZMX, or now Zeometrics. So definitely credit there. All right. And so wrapping up a little bit, what are the takeaways you have from this? So I think we can break down a little bit by users versus contributors. So if you're a ZIO user, I think the main takeaway here is just you're going to have a better out-of-the-box experience using ZIO. You're going to have just more tools that are built in for you that make it easier to address some of these very common things of logging, of metrics, of going back to the very beginning, understanding what's going on in your running application with having to do even less on your part. And over time, I think be able to expect more from ZIO ecosystem libraries you're working with, of them providing you with more helpful information about what is going on with them as you're calling into them. For ZIO contributors, I hope this is a little bit of a call to action of, we've got these new tools here, we've got to take advantage of them. And that means we have to collectively figure out how to use these tools. Of, if I'm the author of ZIO Query, I now have an ability to log things and record metrics that I didn't really have before, again, without kind of adding dependencies or doing other things that were problematic. How should I take advantage of that? What's the right level of that I should use that's going to be helpful to users, but that is not going to either impact performance or get in their way or be annoying? And how does that change throughout the stack? The answer may be different for ZIO Query versus a future ZIO Analytics. So I think that's something we need to think about and spend time on together as a community, because I think there's a real opportunity for us there. And then for both users and contributors, I think this is an opportunity for us to work to develop those best practices around using these operational tools, and have a set of standards of, when do we think it, and I'm sure there'll be differences between different organizations and people may have their own styles, but generally, what do we think are the best practices around when you should be logging and how you should be logging, or around what type of metrics make sense to record and how to do it? And there's definitely prior art out there in the general community of people who use those tools, but I think there's also work we can do thinking about how that applies to functional effect systems and to Scala, of what's the best way for us to leverage those tools within what we're doing. And then finally, I want to give a bunch of thank yous here. First to Capital One, who very generously sponsoring this talk with us, and get a chance to hear from Damien as well. And even more from that is just, I unlike some people I work with, I can say that I work with them and I very much enjoy it. They're doing solving some really interesting problems, and it's a group of people I really enjoy working with. So I think, as was mentioned before, I think they're hiring. At Ziverge, we're also hiring. So one way or another, if you're interested in working with Damien, working with myself, working with some of the other folks there on, I think, some really exciting problems that are taking some of these ideas of functional programming, but then trying to apply them to a very large scale. I'd really encourage you to check it out, and hopefully we can have some fun together. Also like to thank John for his leadership of ZIO community, and we're also just getting a chance to work with him, obviously, on a professional basis at Ziverge as well. It's always a real pleasure, and I mean, some of his original ideas have made a lot of this possible. So definitely want to give credit there. And then Sandra, I want to thank Sandra. She did a ton of work in organizing this event and does a ton of work behind the scenes and making a lot of these things possible, whether it's this, whether it's the Symposia, any of the other events you see. And a lot of times I think it's thankless work, of it's kind of doing the behind the scenes things so this stuff happens. So really want to say thank you there. Also want to thank all of the ZIO contributors and users. I tried to call out a couple of people who I think did major features that went into these particular components of logging and metrics, but obviously it's a team effort, and there are a lot of different components that go into both ZIO in general, ZIO 2.0, as well as just it's all the users who are using it, who are giving us feedback. All of that's what makes this possible. So thank you to all of you. And then finally, just thank you for people taking the time out of your day to listen. I know we're all busy, and really appreciate you taking the time to listen here. And hopefully you found this valuable and helpful. So with that, I will turn it over. And if we have any questions, we can do that. Or otherwise, I'll let you go back to your regularly scheduled lives.